Here, how the corrosion is taking place actually. Corrosion is nothing oxidation process, but that is not explained simply. It is explained by the photochemical process, right? So before that, how the corrosion is taking place, we will discuss, right? So here, simply for this, you require a new iron nails, right? So they are actually enough, but you are understanding the conditions here. What suitable conditions are required, right? Which conditions are helping the corrosion process, that you are understanding. So for this, you need to create the different types of conditions, right? So for them, you are taking three boiling tubes here. Three boiling tubes. So here, taking the three boiling tubes, you are creating the different conditions, right? So drop two or one iron nail into each new shiny iron nail. New shiny iron nail into each test tube. Then what to do? Here, one of the test tube filled by water, right, up to the level which allow the nail to sink, the level which allows the nail to sink partially, half of the level, right? The next one completely filled to sink the nail into the water. There is water in the both test tubes. Okay. Then third one, no water. Right. So here, just I am closing the first test tube with the rubber cork. So here, in this, air gets trapped. Right. In the second one, I don't want to allow this air in contact with this water. So for that, I am adding here a layer of oil to avoid the contact of water and air. So here, only water is in contact, but no contact with the air. So I created two different conditions here. One, first test tube A is creating that conditions which that a nail especially, which is in contact with the both mediums, water and the air. Then in the second one, the nail is allowed to come in contact with the water only. In the third one, you have no water, air is there. That air also maybe contains water vapor. So how to remove that? For that, just here I am adding one chemical substance which can absorb water. That is anhydrous calcium chloride. It can absorb the water vapor from the air. Then I am closing the test tubes, boiling tubes with the rubber corks. So we are created different situations here. So look at them in the diagram. Three different conditions are given here, weather conditions or climatic conditions, whatever it may be. So here, after 2 days, 1 day, or maybe few days, then take them out. Nails, you can take them out and observe. So which nail gets rusted? You can see that nails gets rusted only in the first test tube. No rust formed in the second, and no rust formation on the nails of a third test tube. Why maybe here? Because your provided conditions are different here. So what you notice, especially in the test tube A, that nails are in contact with the air and also with water. So due to this reason, maybe the rust formed, right? Then here in the boiling tube 2B, test tube or boiling tube B, there is no contact with the air, only it has contact with the water. Then in the third boiling tube C, there is no contact with the water, only it contacted dry air, just in contact with the dry air. So due to this reason, maybe they do not form rust. So what are the conditions are required? That conditions are nothing. They come in contact with the air and water, then only get rusted, right? So these are the observations in this activity, right? So read carefully. So what are the conditions you noticed or observed here? Simply we observed that conditions are here. It must be in contact with the air and water. Due to that, what happened? Metal gets oxidized. Metal gets oxidized here, right? Metal gets oxidized. So due to that, simply here they are forming oxides, respective oxides, metal oxides. So that is only here calling as rust. So corrosion of iron, commonly what we are calling as rusting, occurs only in the presence of air and water. So the chemistry involved in this formation of rust will be explained by the electrochemical phenomenon. Electrochemical phenomenon. So during the corrosion at a particular region on the metal surface, right? Particular region on the metal surface that can form the ions, right? Oxidation takes place. What is actually oxidation? That oxidation and reduction will be explained by another process also. What that is actually losing of electron and gaining of electron. So at one of the spot, oxidation will take place. That means that loses electrons. That spot act like anode, right? So at that anode, what happens? Observe here. So at that spot, it act like anode. At one of the region, that water combining with the carbon dioxide, moisture present on the surface of metal, combined with the carbon dioxide and forms it is carbonic acid, H2CO3, right? H2CO3. Then the metal reaction with the acid we know displaces hydrogen gas and forms the salt. So in this, that available water, right, dissolution of acidic oxides, right, may be formed in the atmosphere. So this spot behave like a cathode. This spot behave like a cathode. So here at the cathode, oxygen loses its electron, hydrogen loses its electrons. So they are here forming separate ions. So metal ion and hydrogen ions are formed here. That hydronium ions are combining with this oxygen to form a vapor, water spots, right? Then this iron will be left as here positive ion. Iron will be left as positive ion in the liquid form. So simply they slowly converted. So this iron ions again reacting with the oxygen available in the atmosphere. So they are left as here simply as Fe2O3 XH2O. Fe2O3 XH2O. XH2O here number of water molecules combined with the iron oxide, right? So actually this is electrochemical phenomenon, which helps to explain the corrosion process. What the reaction takes place at the anode and what the reaction takes place at the cathode, that you need to explain. So here, okay, we know about that electrochemical phenomenon. Is it possible to control that electrochemical process. Yes, we are able to control that process, right? So that is only here prevention of corrosion. If that electrochemical process is taking place, the metal will be corroded. If you are able to control that process, automatically what happens? That metal will be preserved or stored for a long time without any corrosion. So due to that reason, you are avoiding contact of oxygen and water. If you are able to avoid that contact of water or air, then automatically what happens? Electrochemical process will not take place. So that is only preventive method, right? Avoiding the contact. So how to avoid that? Using a layer on the surface. What this layer is actually least reactive. So maybe covered the surface of metal by plastic, do not react. A least reactive metal, it also takes many years of time to react, right? Using a layer which can avoid the contact of water and avoid the contact of air and itself do not wet. That is only here paint, oil coating, applying greases, anything. So these are the preventive methods. So in this, we have two methods chemically. What they are here? Galvanization and electrolyting. Sorry, electrolysis. Galvanization and electroplating. What they are actually? Here, galvanization is a method applying one of the metal as a layer on the other metal. So that metal is specially here zinc. So zinc is coated as a layer on the metals. So it can avoid the contact with the air, right? So this is galvanization. Then one more is there, electroplating. It is electrolysis process actually. Least reactive metal will be displaced and coated as the layer on other metals. So that is electrolysis process. One more is there, alloying. So alloying is a method that which can combine different metals. Metals combined together, right? So that combination of metals in a ratio is called alloying. Suppose here, if you think about the gold, in that you are using two different values, 24 and 22. Why we are using to know about the purity of the gold, right? Expressed in terms of carats, right? 22 carats, 24 carats. So 24 carats gold is pure gold. 22 carats gold is containing copper or silver in it. Copper or silver. So that copper or silver combined with the gold, that is called an alloy. For example, for your wheels also you are saying alloy wheels combined, do not get rust, right? Steel, old wheels that gets rusted after many years, right? So these alloy wheels do not rusted, and its quality comparing with the steel is different. Its quality improves by alloy. The best qualities they can perform by the alloy. For example, here I said about 22 carats gold. How they can change the purity of the gold? Simple. So here among 24 grams of gold, they can take 22 carats gold, 22 grams of gold, and they can add 2 grams of copper or silver. 2 grams of copper or 2 grams of silver. They can mix in molten state. So that is called alloy. Why they are? To change the nature of gold here. Actually 24 carats gold brittle in nature. Brittle means breakdown. You are able to break it easily. For example, piece of chalk, brittle in nature. If you take a plastic, not brittle, right? Soften. So that you can change here. That you can change here. So simply that to make soft material, soften the gold. Why? Here to make a string, right? To make a string, they need 22 carats gold actually, right? So that's why they are combining gold and copper or silver. So this is the importance of alloying here, right? But 22 carats is required, but 22 carats gold is not pure. See here, this table will provide that method of alloying, right? The next here we have few important processes. In that I discussed two processes in a previous classes. That is here roasting completed and calcination also completed. Then we are discussing only two remaining important process. That is here smelting, and one more is about a device which can carry out the roasting process. That is reverberatory furnace. So blast furnace is used for reduction process, reducing, right? Reverberatory furnace is used for roasting process. Remember that. Blast furnace is used for reduction process, and reverberatory furnace or retard furnace is used for carry out the roasting process. Then here actually this is smelting, roasting, calcination, or here pyrochemical process. Smelting, roasting, calcination are required high amount of heat energy. That reactions or the process which can be completed in the presence of heat, they are called as here pyrochemical process. Here pyre means heat. So that's why they are named as here pyrochemical process. Only here you need more amount of heat energy, increasing the temperature for higher temperatures, more than 1000 also sometimes, right? To get them in molten state, right? To get them in a molten state. So obtaining molten state, then adding here simply flux. What is here flux? Flux is a substance, right? And it is combining with the impurities. That can react only with the impurities. So here it is a substance which can react with the impurities. So based on the impurities only you are selecting the flux here. So that flux may be with acidic nature or basic nature, right? So that acidic nature flux will be selected based on the impurities. If impurities are basic in nature, acidic flux will be selected. If the impurities are acidic in nature, basic flux are selected here, depending on the impurities nature, right? Acidic substances with the flux basic nature, basic impurities with the acidic flux opposite. Okay, so that you need to remember here. So flux is used, and also we use fuel to get heated strongly, right? So here for example here, to obtain iron, right? To obtain iron, we are using, for example here, is during the smelting the impurity is gone in the what iron, right? What they are here, hematite, right? Hematite, iron oxide. It is nothing, iron oxide. In that we have impurities. So to remove that impurities, we are using coke ice here, fuel, coke ice, fuel, and limestone is used as flux. Limestone is used as flux here. So remember that. In the process of hematite, we are using coke ice, fuel, and limestone as a flux here. They can react. Limestone react with the impurities present in the hematite in molten state, right? So fuel is used to produce the heat energy, And also by burning the fuel, we are able to get gases that which can reduce again. So you are heating the carbon in the absence of oxygen actually, that produces heat energy and liberates carbon monoxide gas. That carbon monoxide is used as reducing agent. That carbon monoxide here reacting with the iron oxide. This carbon monoxide is used as reducing agent here. Remember, carbon monoxide is used as reducing agent, removing the oxygen from the iron oxide, right, with the carbon monoxide, and it will be liberated as carbon dioxide escaped. Then iron will be left in the liquid form, right? In the liquid form, you will obtain iron here. So here the carbon dioxide liberated. Then here that flux we used calcium carbonate. So when you heat calcium carbonate, it will be remained as calcium oxide and carbon dioxide. Carbon dioxide will be liberated. Then calcium oxide we obtained in the solid form. That calcium oxide is going to be react with the silicates. Silicon dioxide, right? That soil particles, SiO2 remain in that remaining substance, silicon dioxide, will react with the calcium oxide and removed as calcium silicates in the liquid form. So their liquid water temperatures are different. So at one of the state, right? So that density is also different. So one can be float and one can be sink. So using that technique, at one of the stage, that different heights, you can collect a molten slag and a molten iron. So one can be float, one can be sink. So that using here, the technique we are using here, then you are separating the molten iron and you are obtaining the molten slag. Slag means impurities only. Gong, slag, both are same, right? They are impurities. So this is about a smelting process. Got something clarity? Vikrant, Sricharan, Abhinay. Got an idea about smelting? Yes, right? So read that smelting process like this. Don't depend on the information, depend on the equations. That is helpful, easy, right? So now we will discuss about remaining thing, that is here simply a roasting process. Smelting flux completed. Flux in the smelting only I explained. Flux is a substance that which is added to the ore to remove gong by the reaction as a liquid form called slag, right? So in that process, you are selecting the acidic flux and basic fluxes, right? So they convert finally into silicates here. Calcium silicate, iron silicate, right? So now here you are learning about the furnace. So furnace is nothing. It is a special built chamber that which can carry out the roasting process. It contains mainly three parts. They are here: firebox, hearth, and chimney. Firebox, hearth, and chimney, right? So that three important parts are there. That only we are discussing here in the reverberatory furnace, right? So chimney, it is simply outlet for what? Gases. So here in the pyrochemical process, you are producing the gases. For example, in the smelting, we observed carbon dioxide. In the roasting process, sulfur dioxide, that can be released through this chimney outlet, right? So that floating particles and the gases will be released, allowed to escape from this chimney, right? Outlet it is. The next here, simply firebox. Firebox is what? It is a place where you can burn the fuel. where we can place the ore, where we can place the fuel to burn it, to produce the heat, right? So that is here firebox, right? Fuel kept for burning. Fuel kept for burning. So chimney is outlet to release gases, wastage. Then hearth is a place where we can place the ore, right? Where we can place the ore. So ore is placed on the hearth. Then here, reverberatory furnace have a contact of gases, right? Hot gases, right, will be supplied over the hearth where you place the ore particles. So from the firebox, you are producing the hot gases. That hot gases will be supplied over the ore particles, right? So that gases will be here released, allowed to move here. So this is your arrangement called reverberatory furnace, right? So the diagram is clearly given here. See here, firebox, right? Firebox to burn the fuel here. That hot gases allowing over the surface of ore, then the impurities gets removed by the reaction, right? So that sulfides are converted into oxide forms, then you will get the ore in the form of oxide, then further reduced using the different process here, right? Then one more type of furnace is there, that is retard furnace. So reverberatory furnace has here contact between the hot gases and the ore, but in the retard furnace there is no contact of at least gases here. There is no contact. Just by the radiation process, they can supply the heat energy, right? So that is the difference between the retard furnace and the reverberatory furnace. There is no contact. At least that flame or gases do not touch the ore here, right? Remember that retard furnace also, it is given in the last paragraph, right? So this is about your syllabus.